Last chapter of the year. Doesn't mean it's time to sit outside and not watch your videos. You do want to go outside, but make sure you get your videos done. We're moving into three-dimensional shapes, 3D formulas, 3D volume, surface area. So what we've done in chapter 9, but adding in a third dimension. So we're going to go through some basics today. Want to make sure we can use some of these formulas that will be helpful when we get into 3D figures. Excuse me. So a couple of vocab words first. Vertices, edges, and faces. So vertices are these points that I just labeled. There's one in the back there. In this case, there's 6 of them. And they're basically like the corners. If you want to think of it as the corners or points where the edges meet. So those are our vertices. Our edges, again, probably easy to figure out what our edges are all these. Edges are kind of like the creases or the points at which the planes meet. So our, if you want to think of them as creases or whatever works for you, and that's where our planes meet, or faces. Okay. Last part is the faces, which you can see there. I'm going to kind of try and shade some of them in. So you can see we have 1, 2, 3, and then 4 faces in this case. And those are planes or flat surfaces. Those are our two-dimensional objects. So in this case we have a couple rectangles and a couple triangles. Anytime we count our vertices, edges, and faces, we should always have our vertices minus our edges plus our faces equaling 2. That's Euler's formula. And what it says is if that's true, then it's a polyhedron or a many-sided figure. So what we're going to do, we're just going to count, which sometimes it's easier than it actually is. And we're going to see if it works, and these are polyhedrons. So find the number of vertices, edges, and faces, and then use your results to verify. So vertices, 1, 2, 3, 4, 5, 6. Edges, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 edges. And it might be good to highlight them just like I'm doing because it's easier to count. And then we have 1 bottom base or face, 2 triangle faces, and then a back with the rectangle, so we have 4 faces. So we're going to test it, and we're going to say our vertices minus our edges plus our faces, does that equal 2? Well, 6 minus 9 is -3. Plus 4, does that equal 2? Well, -3 plus 4, is that 2? And no, it's not. So it's not a polyhedron. Maybe I made a mistake. Let's see. Faces should have been, oops, I'm on the wrong spot. This is my old notes. There we go. Our faces from our old notes, that's why I went back and checked, those should have been 5, and that's why I told you it's easier said than done. 5 faces. You have 1 on the bottom, 1 in the back, another one here, so that's 3 so far, and then you have the back one, 4, and then you have the slanted one in front, which is 5. I knew our answer should have been, yes, it is a polyhedron. It's -3 plus 5 equals 2. Yes, it is. So, glad I caught that mistake there. Same idea number 2. Hopefully I can count a little bit better this time. Vertices. We have 1, 2, 3, and then there's a 4th one back there you can't see. 5, 6, 7, 8, 9 vertices. Edges, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 edges. Gotta be really careful counting them. Hopefully I don't make a mistake with the faces this time. And our faces, it's going to be 1 on the bottom. So that's 1 plus 4 on the sides. It's going to be hard to shade them here, so I'm not going to do that. 4 on the sides, so that's 5. You cannot count this one here because you actually can't see that face. It's not part of the outer object. It's being covered by the pyramid on top. So we only have 5 so far, and then we have 4 on top on the pyramid, so we're at 9. So our vertices, 9, minus our edges, 16, plus 9, does that equal 2? So let's see, negative 7 plus 9, does that equal 2? Yes, it does. So it does meet Euler's formula there. Okay, so it's a polyhedron. Alright, distance in 3 dimensions. Let's first remember, if we can remember, distance in 2 dimensions and midpoint in 2 dimensions. So distance formula, hopefully you remember, x2, not x squared, x2 minus x1 squared plus y2 minus y1 squared. It doesn't matter if you flip your x's and your y's, I just do the x's first because that's what comes first. Your midpoint, if you remember, that's your averages of your points. So x1 plus x2 all over 2, y1 plus y2 over 2. Hopefully you remember those. Those are things that you need to memorize. Just like 2 dimensions, we also have that in 3 dimensions. If you look at this, all we're doing is adding on a z. Okay, in 3 dimensions, instead of on your coordinate plane, you have a little bit different. You have a third dimension here. We're kind of out here. So this is maybe your x, this is your y, we'll call it, and this is your z. So you can go outwards in kind of into space there. Okay, so those are your formulas that you will need to know. Let's try a couple. Find the distance, find the nearest hundredth, find the midpoint. So I'm probably going to do the first one and let you guys do the second one. So distance, I'll do that one first because it takes a little bit longer. So I have x2 minus x1 squared plus y2 minus y1 squared plus, and here's your z, which is always your third number. So let's just go ahead and I'm going to label these for you guys so we don't forget, and just start plugging in. So we have the square root of x2 is 4 minus x1 is 6 squared plus y2 is 6 minus y1 is 11 squared plus z2 is 13 minus 3 squared. So we get negative 2 squared plus negative 5 squared plus 10 squared. One more step and then I'll punch in the calculator. 4 plus 25 plus 100. So that's going to be equal to 129. The square root, I'm just going to go ahead and give us a decimal here. Square root of 129 is about 11.36. And that would be our distance here. Midpoint, just like we did before, same idea. Our midpoint is going to come from a little easier formula. Maybe I'll start in black again. You're going to have x1 plus x2 all over 2, y1 plus y2 all over 2, and z1 plus z2 all over 2. You're finding the averages of all those points. So I'm going to do this same idea again. And we have 6 plus 4 divided by 2. We have 11 plus 6 divided by 2. We have 3 plus 13 divided by 2. So that's going to simplify to, let's see, 6 plus 4 is 10, divided by 2 is 5. 11 plus 6 is 17, divided by 2 is 17 over 2. We'll leave it just like that. 3 plus 13 is 16, divided by 2 is 8. And that's our midpoint. So midpoint obviously a lot easier than distance. Doesn't take us long, but those are the ones that we'll have there. Okay, we can do 4 together tomorrow. Using distance formula, we can also find the length of the longest diagonal of a rectangular prism. So like a shoebox from one top corner to the other bottom corner on the diagonal from it. We have 2 ways we can do this. You can either A, use Pythagorean theorem twice, which I'd suggest not doing, or B, just use the distance formula except for you're square rooting the left or the right side and the left side to get rid of this square. If you do it to the left side, you do it to the right side, that's where we end up with this. So I'm going to show you using Pythagorean theorem twice. What you do is first, our goal is to find that. What you would have to do first is find this here. You'd have to find that, and then use that along with this edge to find your other diagonal. So you're going to have to use Pythagorean theorem twice. You can do that, or you can just use this formula, and that's what I'm going to do. So the diagonal is equal to the square root of L squared plus W squared plus H squared. And this is actually even easier than distance formula. We want to find the length of the diagonal. Oops, the diagonal, so that's our unknown. I'm going to go ahead and do that now. So D equals the square root of, let's see, length we'll say is 12 squared, plus our width we'll say is 16 squared. It doesn't necessarily matter which one's which in this case. It will matter in the next one. Plus our height is 21 squared. Again, you're just adding, so the order is not necessarily important. So distance equals 144 plus 256 plus 21 squared. I think I know what that is. Okay, that's what I thought. Wanted to double check. Alright, so our diagonal is going to be, the distance of our diagonal is going to be, let's see, 256 plus 144 equals 841. I can check and see if I can take the square root of that, and it does work. Good thing. Our diagonal is 29 meters. So it's just distance formula except for your square rooting both sides. Number 6, find the height of a rectangular prism. Okay, so now we're trying to find height of a rectangular prism with a 14 by 14 inch base and a diagonal with a length of 28 inches. Give an exact answer. Okay, so diagonal equals L squared plus W squared plus the height squared. And we want to find the height. So we're not going to know what that height is. We do know what the length and the width are in the diagonal, but not the height. So we're just going to start plugging stuff in. The diagonal is 28, which is the longest, which should always be the case, equals the square root of L squared. So the length is 14. It's a 14 by 14 inch base, so is the width. The height we don't know, so we're going to leave that alone. Okay, to get rid of that square root, we're going to square both sides. We can't do anything until we get rid of that. So 28 squared is going to give us, let's see, 784 equals, now we're just left with 14 squared plus 14 squared plus 8 squared. We'll go ahead and do 14 squared. And that's 196 plus 196 plus 8 squared. So 196, two of them is going to be 392, I believe. And subtract that from both sides. And you end up with 392 equals 8 squared. Take the square root. It says give an exact answer, so my feeling is I have this as a decimal. Oh well. We're going to have to break this up. So let's see. 392, I'm going to try and go maybe with 16. I'm feeling 16. Nope. 392 divided by 8 maybe? Yep, that works. So I'm going to have to do 8 and 49, but I picked a pretty good number. That's 2 and 4, 2 and 2. But this is 7 and 7. That's the part I like. So a pair of 7s, pair of 2s, a 2 that stays inside. So the height is going to be equal to a 7 that came out times a 2 that came out and then a 2 that stayed inside, or 14 radical 2. My unit was inches. Okay, so make sure if it says exact answers to go ahead and do that. Let's do maybe one more of these. Find the length of a diagonal of a 3 inch by 6 inch by 12 inch rectangular prism. Round your answer to the nearest 100. Alright, so now we're allowed to round, which is good. So diagonal equals L squared plus W squared plus height squared. D equals the square root of, because we don't know the diagonal, that's the one we're trying to find. It's not a working backwards. L squared, we'll call that one 3. Width we'll call 6. Height we'll call 12. Again, it doesn't matter, you're just adding. So diagonal equals 9 plus 36 plus 144, which is going to give us, let's see, 144 plus 45 is going to be 189. You could try taking the square root of that. You get a decimal, and in this case we're allowed to have the decimal to the nearest 100. So 13.7477, etc. So it's 13.75 inches is the diagonal length. I want you guys to do this one for tomorrow. So number 8 is the one you guys need to do. We'll do that other distance one together, distance and midpoint. You do need to do number 8 if you want credit for your notes. It's just like number 6, so if you need to go back and look at 6, that's the one you want to focus on. I'll see you guys tomorrow.